This is Geometry Unit 6, Lesson 9, on proving right triangles congruent using hypotenuse leg. Now, the fifth and final way we have of proving triangles congruent is by hypotenuse leg. But it only works when you have a hypotenuse. And when do you have a hypotenuse? When you have a right triangle. So, hypotenuse leg only works on right triangles. So part of proving hypotenuse leg is that you have to prove that you have right triangles in there. But we'll get to that in just a minute. So, it only works on right triangles. So let's see why it only works on right triangles. Let's take a look at my two triangles that I have here. The hypotenuse leg theorem says if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse leg of another right triangle, then the two triangles are congruent. Now, why does this work? Well, let's see what we have here. I have my two triangles A, B, and C, ABC and DEF, that are right angles. So triangle ABC with right angle C and DEF with right angle F. And I know that AB is congruent to DE and BC is congruent to EF. So AB and DE would be the hypotenuse and BC and EF would be the legs. So, and this is a right triangle, of course. So let's prove why hypotenuse leg works. Well, let's think about what we know about these triangles. All right, now for clarity's sake, I'm going to rename each of these sides something. So the side across from angle A is going to be little a, the side across from angle B is going to be little b, and the side across from angle C is going to be little c, and same thing over here. D across is going to be little d, E is going to be little e, and F is going to be little f. So that actually means AB is congruent to DE. That actually means that C is equal to F, that's the hypotenuse, and BC is equal to EF actually means BC is side A, is going to be equal to EF, which is side D. Okay, so that's just equivalent, just for working sake. All right, so first of all, since we know that these two triangles are right triangles, what should be true about the sides? Well, by the Pythagorean theorem, because these are right triangles, a squared plus b squared should equal c squared. And for the other triangle, d squared plus e squared is equal to f squared. That's what we know about right triangles. So by the Pythagorean theorem, we know that that's true. Now, we are given in there that c is equal to f, which is given. So if c is equal to f, does not imply that c squared is going to equal f squared. If you square them, they're still going to be equal. Yeah, that's multiplication property. So if we take c squared is equal to f squared here and here, by substitution, if c squared is equal to f squared, we can say, well, here's c squared, here's f squared. That means that a squared plus b squared is equal to d squared plus c squared, or e squared, sorry, is equal to d squared plus e squared. So I'm just taking this, plugging in a squared plus b squared, taking this, plugging in d squared plus e squared. So by substitution, that's true. So we have used this given right here. Now, we also know that a is equal to d. So if a is equal to d, that's given, that implies that a squared is equal to d squared. So what can we do with these two statements right here? Well, we can end up with a squared and take it out, and d squared take it out, and we're left with, by subtraction, that b squared is equal to e squared by subtraction. Now, b squared being equal to e squared implies that b is equal to e. If I take the square root of both sides, I'm going to end up with b is equal to e. So we have just proved now that b is equal to e. So are these triangles now congruent? Yeah, triangle ABC is congruent to triangle DEF by side, side, side. So therefore, proving hypotenuse leg works. That's why hypotenuse leg works, to prove the triangles. So all you have to do to prove right triangles congruent is prove you have a right triangle, prove the hypotenuses are congruent, and one corresponding leg is congruent. So let's actually apply hypotenuse leg in a proof. We have AB is congruent to DC. These two sides are congruent. We have AB is perpendicular to AE, which makes a right angle here. And we have CD is perpendicular to CF, right angle there. And we also have that BF, this little piece, is congruent to DE. All right, now I'm going to draw my triangles out separately. I want to prove that AE is parallel to CF. AE, CF. Well, if I want to prove them parallel, I've got to prove something about the angles. And to prove something about the angles, I probably have to prove the triangles. So I'm going to draw my two triangles here. All right, so here is my first triangle, ABE. ABE. And then I'm going to draw my second triangle that corresponds to it. So I'm going to draw it exactly the same way so it corresponds. All right, and my right angles at C. And then D corresponds to B. And then F corresponds to E. All right, so there's my two triangles that I'm trying to prove. Okay, now, I know this is going to be hypotenuse leg. So, if I look at here, first thing I have to prove is that I have a right triangle. So what's going to prove that I have a right triangle is the perpendiculars. So I'm going to start with those. AB is perpendicular to AE, and CD is perpendicular to CF. That's given. All right, so AB being perpendicular to AE gives me that angle A is a right angle, and over here, CD and CF being perpendicular gives me that angle C is a right angle. So these are right angles, because we know perpendicular lines give you right angles. Actually, congruent right angles, if you want to put that. Perpendicular lines form right angles. Okay, now why did we want the right angles? Because we wanted to prove they're right triangles. Well, what's the definition of a right triangle? It's a triangle that has a right angle. Well, we can say triangle ABC and triangle DCF, or CDF, sorry, CDF, are right triangles. Okay, because right triangles have a right angle. Okay, now remember, the reason we have to prove that we have right triangles is because we're going to prove hypotenuse leg. All right, now let's see what we have in the triangle. We have the right triangle. So we have AB is congruent to DC. AB and DC are congruent. Okay, that's given. That gives me the leg. All right, so there's the right triangle. This gives me the leg. That's the right triangle right there. And now I need to prove the hypotenuse. Well, what part is the hypotenuse? Well, here's the right angle, so the hypotenuse, I have to get BE congruent to DF. My other given that I have is BF is congruent to DE. That's given. Now, to get the whole side BE and DF, I have to add EF in there to both sides. So EF is congruent to EF by reflexive. And then I can add BF plus EF to get BE is congruent to DE plus EF, which is DF. And that's using addition. So I have now proved that BE is congruent to DF, which is this side is congruent to that side. So have I proved hypotenuse leg? Yes, I have. Triangle, this is my hypotenuse right here. Triangle ABE is congruent to triangle CDF using hypotenuse leg. Now, again, with hypotenuse leg, you have to make sure that you prove you have right triangles before you can prove hypotenuse and leg, because you don't have a hypotenuse unless you have a right triangle. All right, now we want to prove that AE is parallel to CF. All right, so we're trying to prove that these two sides are parallel, right here. Parallel lines are parallel when what angles are congruent? alternate interior angles, corresponding angles, or interior angles on the same side of the transversal. Well, if this is my transversal right here, because that's the line that connects the two, what angles would be congruent that correspond? Well, look at my picture here. How about E and F? Isn't that this angle and this angle? Yep, they are. So are they congruent? Yes, they are. So I would say angle, now you have to make sure you tell me which one that is, AEB is congruent to angle CFD. And why are they congruent? Because of CPCTC. Corresponding parts of congruent triangles are congruent. Now, since those angles are congruent, they are alternate interior angles. That means that AE is parallel to CF. Because if alternate interior angles are congruent, then lines are parallel. So we have proved what we wanted to prove. We have proved that AE is parallel to CF. So hypotenuse leg, remember, you have to prove you have right triangles, prove the hypotenuses are congruent, and the legs are congruent. So hypotenuse leg is our fifth and final way of proving triangles congruent.